Hello dear students, now we are going to learn about free fall. What do you mean by free fall? When an object is thrown upward, it reaches certain height. Then it starts falling down towards the earth. It is because the earth's gravitational force exerts on it. This fall under the influence of earth is called free fall of an object. Or we can say that when a body falls from a height towards the earth only under the influence of gravitational force, the body is said to have a free fall. And the body having a free fall is called a freely falling body. It is said because only under the influence of gravitational force, because when we put two objects of different mass, it may not reach the earth at the same time, because not only the gravitational force is acting on the body, there will be air resistance. For example, if we drop a coin and a feather from a certain height, both the coin and feather will not reach the ground at the same time. It's just because air resistance is acting on the body. If it falls only under the influence of gravitational force, both feather and coin simultaneously reaches the ground, that is, it reaches the ground at the same time. It was Galileo who first demonstrated that the acceleration of an object falling freely towards the earth do not depend on the mass of the object. Imagine that a vacuum is created by evacuating the air from a glass jar, as you have seen in the figure. Then the feather and the coin will fall with the same acceleration and reaches the ground at the same time. So during this free fall, direction do not changes, but velocity continuously changes, which is called acceleration due to gravity. If there is a change in velocity with respect to time, then there will be an acceleration, and this acceleration due to the gravitational pull of earth is known as acceleration due to gravity. So we can define acceleration due to gravity as the uniform acceleration produced in a freely falling body due to the gravitational force of the earth. Its unit is same as acceleration. And what is the unit of acceleration? Meter per second square. So acceleration due to gravity is also having the same unit, that is meter per second square. And we can calculate gravitational acceleration or the acceleration due to gravity at different places on earth. It is different at different places on earth. It varies. Acceleration due to gravity on the surface of the earth is 9.8 meter per second square. How we can calculate that? We know that F is equal to gmm by d square. If the object is on the surface of the earth, then the distance from the center of the earth to the center of the body is nothing but the radius of the earth. So we can rewrite the equation as F is equal to gmm by r square, where r is the radius of the earth. Since the object is at the surface of the earth, we can take the radius of the earth as the distance between the object and the earth center. And we know that the force exerted by the earth produces an acceleration on the body. From Newton's second law of motion, we have learned F is equal to ma. Here, the force exerted by the earth produces the acceleration. So, that acceleration is acceleration due to gravity. So, A becomes g. So, F is equal to mg. So, we have got two equations. When we compare two equations, we will be getting mg is equal to gmm by r square, or acceleration due to gravity g is equal to capital Gm by r square, where capital letter G is gravitational constant, and if we are calculating the acceleration due to gravity of earth, m is the mass of the earth and r is the radius of the earth. So, we can calculate acceleration due to gravity g on earth is equal to gm by r square. We can calculate that value on the surface of the earth, acceleration due to gravity on the surface of the earth. As we said, g is equal to gm by r square, and we know that value of capital letter G, that is to 6.673 into 10 raised to minus 11 Newton meter square kilogram raised to minus 2, and m is the mass of the earth, that is 6 into 10 raised to 24 kilogram, and r is the radius of the earth, that is 6.4 into 10 raised to 6 meter. So, when we substitute this in the equation, g is equal to gm by r square, that is 6.67 into 10 raised to minus 11 into 6 into 10 raised to 24 divided by 6.4 into 10 raised to 6 the whole square. When we solve that, we will be getting g is equal to 9.8 meter per second square. So, this is the acceleration due to gravity on the surface of the earth, 9.8 meter per second square. And for simplified calculations, we can take it as around 10 meter per second square. But there is variation of acceleration due to gravity at different places, even on earth. So, let us consider the first case, variation in the value of g with the altitude above the surface of the earth, or if the object is at a height above the earth, then acceleration due to gravity decreases. That is, acceleration due to gravity decreases with altitude. The equation will become g is equal to gm by r plus h the whole square, because the object is at a height h from the center of the earth. So, we have to add that height with the radius of the earth. So, the denominator become r plus h the whole square, and hence acceleration due to gravity decreases with altitude. And also, the variation in the value of g with depth below the surface of the earth, that is, acceleration due to gravity decreases with depth. That is, if the object is at a depth d or h, then we can write the equation as g dash is equal to gm dash by r minus h the whole square, where the mass of the earth will be reduced. Therefore, the acceleration due to gravity decreases with depth. We will be considering the smaller part of the earth, so the mass will be decreased. Therefore, the acceleration due to gravity also decreases with depth. It decreases with altitude and decreases with depth. Next case, acceleration due to gravity at poles and equator. You know that Earth is not a perfect sphere. The radius of the Earth increases when we go from pole to equator. That is, acceleration due to gravity is greater at the poles and less at the equator. As the distance increases, acceleration due to gravity decreases. G at poles is equal to gm by radius of the poles square. That is, Earth is slightly flattened at the poles and bulging at the equator. That is, the radius of the Earth at the poles is 21 km less than that at the equator. Since g is inversely proportional to the square of the radius, acceleration due to gravity at poles is greater than acceleration due to gravity at equators. And if we calculate that, we will be getting acceleration due to gravity at poles is equal to 9.823 meter per second square, and acceleration due to gravity at equator is equal to 9.789 meter per second square, and the average value is 9.8 meter per second square. So, acceleration due to gravity is more at poles or equator? It is more at poles and less at equator. Now, let us calculate the acceleration due to gravity on the moon. So, if we calculate acceleration due to gravity on the moon, we will be taking the same equation, g is equal to gm by r square, where g is the gravitational constant, but m is the mass of the moon, not the earth, and r is the radius of the moon, not the radius of the earth. So, if we know the values of mass of the moon and the radius of the moon, we can calculate acceleration due to gravity on moon. The mass of the moon is 7.35 into 10 raised to 22 kilogram, and the radius of the moon is 1.74 into 10 raised to 6 meter. So when we substitute it, we will be getting 6.67 into 10 raised to 11 into 7.35 into 10 raised to 22, the whole divided by 1.74 into 10 raised to 6, the whole square. So when we solve this, we will be getting a value that is 1.625 meter per second square. So the acceleration due to gravity on Earth is much greater than the acceleration due to gravity on moon. Acceleration due to gravity on Earth is around 9.8 meter per second square, but the acceleration due to gravity on moon is 1.625 meter per second square. And as we said, the acceleration due to gravity varies with the Earth's center. When it goes to a certain height above the Earth's surface, the value of g decreases. As you can see here, when the object is above the Earth's surface, 1000 km above the surface, it is 7.33. And on the surface of the Earth, as we have calculated, the value of g is 9.8. And when it goes to greater heights like 5000 km, the value of g is 3.08. And if it is 50,000 km above the surface, then the value of g is 0.13 meter per second square. So, as the object is more and more above the surface of the Earth, then acceleration due to gravity decreases. And also, acceleration due to gravity of different planets is different. We can calculate the acceleration due to gravity of different planets, if we know the mass of the planet and the radius of the planet, it is different. But what about the universal gravitational constant? It is known as universal gravitational constant because it won't vary or it is constant throughout the universe. But acceleration due to gravity, g, varies from planet to planet and place to place. Next, we are going to discuss about equation of vertical motion, or equation of motion when an object is falling freely towards the earth or thrown vertically upward. We have already discussed the equation of motion of a body moving with uniform acceleration in a straight line. What are the equations of motion? There are three equations of motion we have already learned in the first chapter of motion, that is V is equal to U plus AT, S is equal to UT plus half AT square, and V square minus U square is equal to 2AS. When an object is falling towards the earth with an initial velocity U, that is, if the object is freely falling, then acceleration become acceleration due to gravity, that is A become G. So we can rewrite these equations as V is equal to U plus GT, S is equal to or H is equal to UT plus half GT square, and V square is equal to U square plus 2GH, or V square minus U square is equal to 2GH. This is the case when the object is falling towards the earth. If the object is falling towards the earth, we will be taking G as positive. And if the object is thrown upward, then we will be taking G as negative. So, when the object is thrown vertically upward with an initial velocity U, the acceleration due to gravity will be negative. So we can rewrite this equation as V is equal to U minus GT, H is equal to UT minus half GT square, and V square minus U square is equal to minus 2GH, or V square is equal to U square minus 2GH. Next, we can see the difference between acceleration due to gravity and gravitational constant G. Acceleration due to gravity produced on a freely falling body is due to the gravitational force, that is known as acceleration due to gravity. And what is universal gravitational constant? The force of attraction between any two objects of unit masses separated by a unit distance in the universe is known as universal gravitational constant. Acceleration due to gravity is denoted by small letter g, and universal gravitational constant is denoted by capital letter G. The value of acceleration due to gravity g, small letter g, varies from place to place. But universal gravitational constant is constant everywhere throughout the universe. The unit of acceleration due to gravity is meter per second square. The unit of universal gravitational constant is Newton meter square kilogram raised to minus 2. Next is mass and weight. What is mass of a body? What is the difference between mass of a body and weight of a body? Are they same? The mass of a body is a quantity of matter contained in it. And mass is denoted by small letter m. It is a scalar quantity which has only magnitude but no direction. The SI unit of mass is kilogram. And mass of a body is constant and it does not changes from place to place. mass of a body cannot be zero. But what about weight? The force with which an object is attracted towards the center of the earth is called the weight of an object. Weight is a measure of amount of force acting on a mass due to the acceleration due to gravity. This weight is denoted by W. Since it is a force, we know F is equal to ma. So W we can write as W is equal to mg, where g is the acceleration due to gravity and m is the mass. And what about the unit of weight? What is the unit of force? Unit of force is Newton. Weight is a force, so the SI unit of weight is also Newton. And it depends on g, and g is acceleration. So weight is a vector quantity. We can compare the mass and weight. Mass is a property of a matter. The mass of an object is the same everywhere, but weight depends on the effect of gravity. Weight increases or decreases with higher or lower the gravity. And mass can never be zero, but weight can be zero if no gravity acts on a body. If an object is on the space, then we can say that the weight is zero, but the mass will never be zero. Mass does not changes according to the location, but weight varies according to the location because it depends on acceleration due to gravity g, and we know that g varies from place to place. Mass is a scalar quantity. It has only magnitude. Weight is a vector quantity. It has magnitude and direction. And the direction is towards the center of the earth. Mass may be measured using an ordinary balance, and weight is measured using a spring balance. Mass can be measured in kilogram or gram, and the SI unit of mass is kilogram, and weight is often measured in Newton. The SI unit of weight is Newton. Hope you understood the difference between mass and weight. Hope you understood about free fall, acceleration due to gravity, and the difference between universal gravitational constant and acceleration due to gravity. What is the difference between weight and mass? Thank you.